Hey everyone, Chang here and welcome to my channel. This is the bare minimum algebra series, and today we're still going to continue talking about system of equation. Now in my previous video I went over how to solve it through adding and subtracting, otherwise known as elimination. Today we're going to focus on a different way of solving the system of equation, and it is known as substitution. Now, if you saw the previous video, there was a lot of different cases. There was the case 1 with the opposite coefficient, case 2 with the same coefficient, case 3 with the completely different coefficient, and then all of a sudden each and every one of them have their own steps in solving the problem. Luckily for us, if you decide to use substitution, sometimes it can be a little more tedious, but it rules out all the different cases, right? Just by following these 4 steps, you will be able to solve any system of equation. So here's the 4 steps. First, system of equation, there's 2 equations. You're gonna pick any one of them and you're gonna solve for x. In this case, when you're solving for x, all you're really doing is you're isolating x on one side and everything else on the other. When you do that, you move on to step 2. Now, whatever equation you picked and you solve for x, you're going to the second equation and you're going to plug in everything that x is supposed to be because you isolated x. X equals blah, blah, blah. You're going to grab that whole thing, and in place of x, you're going to plug that thing in instead. So all of a sudden you have one equation with only y's. You're going to solve for y, which is our step 3. Once you solve for y is an actual number now. It's not isolating. So with that actual number for y, what you're going to do for step 4 is you're going to pick any one of the 2 equations, the original equations. You're going to plug in y, whatever that value is, whatever that number is, right? And then you're going to solve for x. And after you solve for x, you have what y equals and you have what x equals. Then therefore you have solved the system of equation. So it's these 4 steps. It sounds tedious, and actually sometimes it is, right? However, it's really wonderful because guess what? Any system of equation of 2 variables at least, right, can be solved just with these 4 steps. And this is the process of substitution. So let's look at some examples and how each and every one of these steps play a part in solving it. All right, so let's look at this first example. You have x minus y equals 3 as the first equation. The second equation is 2x plus y equals 12. Now, of course, this seems easy just based on pure experience, or you can see it whatsoever. I'm going to choose the first one and I'm going to solve for x. Remember, in the first step, when you're solving for x, all you're really doing is isolating x on one side and everything else is on the other side of the equation. So if we're looking at this, x minus y equals 3, we just want to move the y on the other side. Since it's a minus y, I'm going to add y on both sides. And the resulting equation is basically x equals y plus 3 or 3 plus y, doesn't matter. There it is, right? So this is wonderful. This is what we need. That is our first step. We solved for x. Now we pick the second equation, and in place of where x is, if you guys can see right here, we're going to substitute this whole thing, y plus 3, in there. So now instead of 2x plus y equals 12, we basically have 2 times y plus 3 plus y equals 12. And remember that this right here was just our original x, right? And then of course, in order to solve it, you have your whole FOIL method, right? Distribute the 2 inside the parentheses. You have 2y plus 6 plus y equals 12. Combine like terms. You have 3y plus 6 equals 12. Subtract 6 on both sides. And let's see, what do we have? We have 3y equals 6. Divide by 3 on both sides because we're just solving for y now. Y equals 2. Now, we're not done. Right, we only have one variable that gives us the actual number. Now what we're going to do is we're going to plug it into one of the 2 and we're going to solve for x. Well, I'm lazy. The first one looks extremely easy. I would plug that in. So instead of x minus y equals 3, so I'm just working with this first equation now, the original one, ignoring everything else. I have x minus 2, right? Remember the 2 is our y now, equals 3. So in order to solve for x, all I have to do is just add 2 on both sides. You have x equals 5, and there you go. Now you have both variables, x equals 5 and y equals 2. And that's how you would solve the system of equations using substitution. Let's look at one more example just to ingrain it in our head. All right, so here's our second example. The first equation is x plus 3y equals 6. The second equation is x minus 3y equals 0. Now, once again, the first step, you can pick any one of the equation. You can usually, if you want, pick the first one. Me, I'm going to choose the second one. And the reason I'm choosing that is just because from experience, or if you guys notice, this is a negative or subtract. If I add it, everything's positive, and usually I like positive because the numbers are easier to work with and I'm lazy. So I'm going to choose the second equation. I'm going to add 3y on both sides because once again, my first step is just to solve for x, or in other words, isolate x. So it's going to be x equals 3y. Okay, well, since I used the first equation, I got to use the second one and plug in this right here, 3y, for where x originally is. So it's going to be 3y plus 3y. And let me just underline this one to know, so you guys know that that is where x originally is, equals 6. Okay, we're going to solve for y now. Combine those two, that's 6y equals 6. Divide both sides by 6, right? You get y equals 1. That is one of our variables. Boom. Right? Now, the next thing you can do is you're going to pick any one of those two and you're going to plug in y and solve for x. Right? I will normally choose the first one, but I'm going to choose the second one just because there's the 0. Right? And it makes life easier. So, x minus 3, and instead of y, we're multiplying it by 1 for this y right here, equals 0. X minus 3, because 3 times 1 is 3, equals 0, plus 3 on both sides. All of a sudden I have x equals 3, and that is my second variable. And just like that, I've solved the system of equation. All right, so there you have it. That's how you solve the system of equation using the substitution method. Now, is one better than the other? Yes. Yes, it is. Right? But it depends on the specific system of equation you're given. If you can get a system of equation that falls under case 1 or case 2 very easily, right, then I would use elimination. Just because adding and subtracting, just getting rid of the variables is wonderful, easy, and amazing. If you cannot and you happen to fall into case 3, if case 3 is an easy number to work with, you can still just go with elimination. If it's not an easy number to work with, then sometimes substitution work. Now the lovely thing about substitution is you don't have to worry about the cases. It will always work. So that's entirely up to you, but it is a case-by-case basis on which one is better than the other, right? Certain cases, elimination works better. Certain cases, substitution work better. Think of it as just a multifaceted, a number of different tools of doing exactly the same thing. Basically, what you're trying to do is solve system of equation. Doesn't matter which one you prefer, whichever one's your favorite, go ahead, use that one. It should yield the same answer. If not, then you're doing one of the methods incorrectly. So, there's that. Anyways, substitution, elimination, your choice. And I will go over one in this next one in the next video. I don't like this method, but it is a method to solve system of equation. So, that's your little sneak preview. Alright, if you haven't already, please like, comment, and subscribe. I will see you in the next video.